Scientific notation. The learning target for this lesson is I can represent numbers in scientific notation, and you should be able to go back from scientific notation into a regular number. So we have two numbers here. We have one on the left, which is the average distance of the Earth to the Sun. And this is, I gotta add my commas in here to make sure I know how big this is. Whoops, gotta change that one over. This is 149,600,000 kilometers. And then on the right side here, we have the density of the Sun's inner atmosphere. And that is a very, very small number. And so in science, we're dealing with these really big and these really small numbers all of the time. And so we got to have a better way of representing these. And that's where scientific notation comes in. Scientific notation is something that you've probably seen before. If you have 2.5 times 10 raised to the fifth, that's scientific notation. Or 3.6 times 10 raised to the negative third, that's scientific notation. Or maybe 1.8 times 10 to the 17th, that's scientific notation. And so one thing that you recognize here is that we have a number with a ones place and a tenths place, and we have a decimal point, and we have a times 10 raised to the some sort of number up here. And that's going to be how scientific notation works. So what this number really is 2, 5, 1, 2, 3, right here, 250,000. Yep. So, and then this number here is 0.136 right there. And I'm not going to be able to write this number out because it's way too long. But we're able to take a really, really long number, one that I can't even write on the screen, and we can write it in this way so that we can better represent it. And so when we're writing down these, when we're translating numbers into scientific notation, we start off with writing the original number, and we're going to go with the distance from Earth to the Sun to start us off here. There we go. 149,000 kilometers. So we're just going to start off by writing that original number. And then our next step is going to be to move the decimal place to make the number between 1 and 10. And so I'm looking at this number here. This is obviously not between 1 and 10, but the number that would be between 1 and 10 would be if I had 1.496. That would be a number that was between 1 and 10. 1.496. I couldn't put the decimal place here because then I would have 14.96. That's greater than 10. And I couldn't put it on the other side of the 1 because that would be not between 1 and 10 either. That'd be too small. And so I'm going to try to get this decimal place to move so that it is between the 1 and the 4 here. So right now the decimal place is right here on a whole number, and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 places to the left. And I'm going to write that down. 8 places to left. That's going to come in handy on our next step. And so that's the second step, is taking that decimal place from the whole number and moving it to make the number between 1 and 10. Then my third step is to rewrite the number, deleting the zeros to the right or left of the decimal place. And so I already had this written. I got rid of it. But if you were doing this problem, you would write down that number between 1 and 10 that you had. So mine would be 1.496. And then I'm going to get rid of all of these zeros because if I have all of these zeros after the decimal place, it doesn't really do me a whole lot of good to have those. Those are just placeholder values. And so that's how we're getting our number to shorten up and be a little bit neater, especially with those numbers that have 17 zeros at the end of them, because we can just get rid of those zeros. We don't have to show those. And so then once we get to this point, we're going to step forward. We're going to write the multiplication symbol and the number 10 with the exponent. So I have my number, 1.496. I'm going to write that multiplication symbol that we saw in all of the others with the number 10, and then I'm going to give the number 10 an exponent. And the exponent depends on however many places we moved our decimal places. So this is going to be an 8. A rule with this is if we move to the left, that means it's positive. And if we moved our decimal places to the right, that means our exponent is negative. And so you'll see that in the last example here. We're going to have one where we're moving it to the right, and it's going to be a negative exponent. But that's how we can remember that. Left is positive, right is negative. And so here is my number in scientific notation. I'm going to note that 146, we'd call this 1.496 times 10 to the 8th, and that was in kilometers for our units. To finish that up, the units would stay. So the density of the sun's lower atmosphere is right here, this really small number. I want you to take a shot at writing this one in scientific notation before you watch the rest of the video. So go ahead and stop the video. Try to do this one on your own, and then I'm going to work through it when you get done. So our first step is write the number. 0.000000028. I'm going to drop the units on this one. So I have 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. Good, they match up. It's a good thing to check to make sure that you're right on that one. And then my second step is going to be move the decimal place to the right or left to make the number between 1 and 10. So I'm looking at this number. If I move it all the way to the right, I'd have 28, and that would not be between 1 and 10. So I'm going to move my decimal place right there is where I'm going to try to get it to. And so I'm going to start here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 places to the right. I'm going to just write 8 right. So I have the number of decimal places, and I know which direction they moved. Now I'm going to rewrite my number, 2.8, deleting all the extra zeros. So these zeros can go away once I get to that point. And then my last step here is going to be write the multiplication symbol with the 10, raise the power. And remember, if we moved it to the left, we are positive, and if we moved it to the right, we are negative. So this one is going to be 10 raised to the negative 8th power. And so our final answer would be 2.8 times 10 raised to the negative 8th grams per centimeter cubed. And that would be our last number in scientific notation, which is a much easier way to represent it. And then if we were going to go from this back in non-scientific notation, we would do is just the opposite of this. I have 2.8 times 10 to the negative 8th. Now I know that I need to move my decimal place. Here, let me move this over. I know that I need to move my decimal place back to the left now. So it's the opposite. So I'd move my decimal over here. 1, 2, 3, 4, 5, 6, 7, 8. Put my decimal here, fill in with zeros. 1, 2, 4, 5, 6, 7. So I'm doing the opposite. And now I have my number of 0.1, 2, 3, 4, 5, 6, 7, 2/8 grams per centimeter cube. That's how we do that. Just the opposite. If I have a negative, now I'm moving my decimal place back out to the left. If I have a positive, now I'm moving it back out to the right. So the goal of this lesson was for you to be able to represent numbers in scientific notation. If you follow those 4 steps every time, you should be able to get it down no problem after a little bit of practice.